We're going to answer both 73 and 74 in one video because 74 is asking us to refer back to problem 73. All right, let's get on to part A of 73. 73 is asking us to calculate the percent composition by mass of each of these compounds. So we'll need our periodic table. Hydrogen sulfide, 2 H's. And the mass of hydrogen is 1.008. This is an intensive property, so it doesn't matter how much, whether it's one molecule or 100 grams or a mole. So the hydrogen component is going to be 2.016, and then the one sulfur 32.06. So the total mass of the compound is 34.07. So let's get the percent composition by mass for hydrogen. So the mass percent of hydrogen in hydrogen sulfide is 5.92%. And for the sulfur component, it's going to be the remaining out of 100%. But I'm gonna calculate it out the same way. (94.10%) or 94.1%. is the mass percent of sulfur. And if you add those two using the digits to the 10th place, then you get 100%. All right, so now let's go right on to 74 while we're at this and answer what's the mass of sulfur in 3.54 grams of hydrogen sulfide. So we know sulfur makes up 94.1% by mass. So we're just going to apply that to the mass of the compound. And you can use your percent function on your calculator, or you can divide that percent by 100 to turn it back into decimal form. So 3.33 grams of that compound is sulfur. All right, now let's go to ammonium oxalate. We'll need the formula to get the percent composition. Ammonium is the polyatomic ion with a 1 positive charge, and oxalate is C2O4 with a 2 negative charge. I'm going to crisscross these to get the ratios of these ions. So we're going to have 2 ammonium ions for every oxalate ion. So we'll need parentheses. So there's your formula for ammonium oxalate. All right, so that 2 outside the parentheses distributes to both elements in the parentheses. So the nitrogen component, there's 2 nitrogens, and nitrogen has a mass of 14.01. So that'll give us 28.02. There's 8 hydrogens. Hydrogen has a mass of 1.008. So that's going to give us 8.064. And then there's 2 carbons. Carbon has a mass of 12.011. Times 2 is 24.02. And then oxygen, there's 4 of them. Each has a mass of 16.00. So that'll give us 64.00. All right, let's add these up. So the molar mass of ammonium oxalate is 124 grams per mole. But again, we didn't need a mole of it or any specific mass of it because it's going to be the same in terms of percent. All right, so for the nitrogen component, it's going to be the mass of the nitrogen over the mass of the compound times 100. That's 22.5. And then for the hydrogen component, .5 is the mass percent for hydrogen. .4% is the mass percent for carbon. And the remaining .6 is oxygen. Let me double check our work. We add these up and it should get to 100%. There it is. So now let's use this to answer 74, which is asking about the nitrogen component in 25 grams. So in 25 grams, 25.0 grams, we're just going to multiply that by the nitrogen's mass percent is 22.5. So if we had 25 grams of ammonium oxalate, nitrogen would make up, or 5.63 grams. All right, on to part C. Magnesium forms 2 positive cations, and hydroxide is a polyatomic ion with a 1 negative charge. I'm going to crisscross these numbers to get the ratio. The formula unit is going to be Mg parentheses OH parentheses 2, because there's 2 hydroxides for every magnesium. All right, magnesium, there's only one of them. It has a mass of 2430. Oxygen, there's 2 of them. Times 16 is the mass for oxygen, that's 32. And then hydrogen, there's 2 of them. And the mass for hydrogen is 1.008. So the mass of magnesium hydroxide is 58.3. 1. So let's get the percent composition by mass for the magnesium component by taking the mass of magnesium over the mass of the compound. 41.7 is the mass percent for magnesium. %, is oxygen. 3.47% is hydrogen. Let's double check our work. We can add these up. We get 100%. All right, so now let's add that. So now let's do 74, where we're asked about just the magnesium component in 97.4 grams of magnesium hydroxide. So magnesium component was 41.7%. So 40.6 grams is magnesium. Finally, sodium phosphate. Sodium forms a 1 positive cation, and phosphate is the PO4, 3 negative anion. So crisscross these to get the ratio. We're going to have 3 sodiums for every phosphate. Sodium's mass is there, 2299. There's 3 of them. $68.97 is the mass for the sodium component. Phosphorus has a mass of 30.97. When there's only 1 of them, and oxygen, there's 4 of them. Times 16 is 64. So the mass of the compound is 163.94. .07 percent is sodium. $18.89 is phosphorus. And 39.04% is oxygen. Let's double check our work and make sure they add up to 100. And they do. All right, so in part D, we're asked for the phosphorus component in 804 grams. So the phosphorus component was 18.89%. So 152 grams is phosphorus.